section 4 and probably reviewing some information that you're familiar with about relations versus functions. Okay, it says any set of ordered pairs is called a relation. All right, if we got an x and a y or whatever you want to call your variables, that's a relation. Okay, it says the first or the set of all first components is called the domain of the relation, and the set of all second components is called the range of the relation. Okay, a function is a relation in which each element of the domain corresponds to one and only one element of the range. So here we have a couple of illustrations that show us what is and is not a function. Here, this makes up a function because every element goes to exactly one element in the range. Even though we've got these two going to the same one, that's okay. All right. However, this is not a function because we have what? 1 point that's going to two different values. Okay, that's not a function. Okay. Let's see, what else would not be a function? Suppose we had in here an extra value that went nowhere. Okay, then that would violate the definition of a function. Okay. So we'll talk about a lot of functions this semester. We'll talk about classes of functions and lots of things we should be familiar with. Here we want to determine whether each equation defines y as a function of x. Okay, and the way that we're going to do that is solve for y. If y resolves to one unique value, then y is a function. If we come up with y is equal to plus or minus something like that, then it's not a unique value and it's not a function. Okay, so for A, is this a function? What can I do to solve for y? Divide by x. So it gives us minus 1 over x. So for each x value that I put into that expression, how many y values do we get out? 1. Okay, so this is a function. Versus in B, to solve for y, what do I need to do? Take the square root and we end up saying plus or minus the square root of x. Okay, so in this case, for each x value that I put in, I can get out two different y's, and that doesn't work. It's not a function. So not a function.
So every time you take the square root, it's going to be plus or minus?
Any even root. 2, 4, 6, any of those. Okay. All right, in C, if I solve for y, we get y cubed equals minus x plus 8. And now I'm going to take the cube root. So we get y equals, with an odd root, I don't have to worry about plus or minus. Okay, so if I put in one x value, how many y values do I get out? Just one. Okay, so it's not a function. I'm sorry, it is a function. I just went to lunch. Okay, function. We put in one x, we got out one y. Okay, questions about that? Okay, so you're already familiar with the function notation, but we'll talk about that as well. We use single letters usually to represent a function. F, or capital F, F, G, capital G. There can be differences between upper and lowercase, depending on, where you are. So don't assume that just because you see F and capital F, that they represent the same thing. They could be different functions. Okay, f of x indicates the value of the function when x is plugged in. So when we talk about f of 3, This indicates the value of the function f when 3 is plugged in for x. You all knew that already. And so now we can very quickly evaluate a few functions, or evaluate a single function at several different values. We're looking at f of 0. That's going to equal what? Negative 5. Very good. Okay, and f of negative 2, we plug in negative 2 for x. So we got 4 minus 8 minus 5 gives me what? Okay, negative 9. All right. F of 1, 1 squared plus 4 times 1 minus 5 gives us 0. All right. From here, what could we say about x equals 1? What happens there? It's an intercept, okay? Good. It's good to recognize that. That would be an intercept. Okay, 1, 0. All right, and then here, if I wanted to plug in a, f of a, I'm going to substitute it in just like we did any other value. And so we get a squared plus 4a minus 5. Okay, if I want to look at f of, I would leave it just like that. Usually if we're factoring, we're trying to solve for something. Okay, but I would leave it just that way. Okay, f of negative x, if I plug that in, we get what? Okay, and so we get x squared minus 4x minus 5. Okay, and the same way for f of x plus 2. Okay, we just got to do it all out. We get x plus 2 squared plus 4 times x plus 2 minus 5. Okay, x plus 2 squared is what? Okay, very good. X squared plus 4x plus 4. This morning in my calculus class, we looked at this. Okay, when we're expanding a binomial, raising it to different powers, this could be very useful for us. I guess I should do this on the board so it'll be in the recording. We start like this, and what this is going to give us is the coefficients for when we're raising it to different powers. So we always have the ones on the outside. To get the numbers in the middle, we add these two consecutive numbers, or adjacent numbers. We get 2 right there. Put 1 on the outside, 1 on the outside. To get this number, I do 1 and 2, gives me 3. 2 plus 1 is 3. Okay, if I did it again, 1 and 3 gives me 4. 3 and 3 gives me 6. 3 and 1 gives me 4. Okay, and like I said, these are the coefficients for when we're raising a binomial to a power. So if I wanted to do a plus b squared, then it's going to be a squared plus 2ab plus b squared. Okay, just using those coefficients. Does that make any sense at all? No. Okay, they loved it. All right, the 1 is right here, understood to be here, and also there. So you see we had 1, 2, 1. We've got 1, 2, 1. Does that make a little more sense? Okay, a little more sense, all right? If I had to cube this thing, then it's going to be 1a cubed plus, my a's are going to go in order of descending power, b is going to go up. So 1a cubed plus 3a squared b plus 3a b squared plus b cubed. Make any sense at all? A little bit. Okay. It's a lot faster. Think about it. But when it comes to raising things to powers, we kind of need to do that quickly if we're going to do it. So this is a quick way to get it done. Okay. But in particular, we'll do this a lot. You want to know what a plus b squared is. So where were we before I digressed? Let's see. So I'm trying to square x plus 2 squared. It's going to be x squared plus 2 times x times 2. I'm writing it out. Plus 4. Okay. All right. Plus 4x plus 8 minus 5. Or x squared plus 4x plus 4 plus another 4x plus 3 x squared plus 8x plus 7. All right, we're done. Okay, questions about that? Okay, the domain of a function. If the domain of a function that is defined by an equation is not explicitly specified, then we take the domain of the function to be the largest set of real numbers that result in real numbers as outputs. So basically we assume the domain is anything that we can put into the function and get a number out. Okay. Notes on finding the domain. Find any values of the variable that do not result in real number outputs. Then exclude those from the domain. When we talk about what's in the domain of a function, usually we start by considering what does not work. That's what this is. Division by 0, of course, is undefined. In essence, exclude from the domain anything that might make a denominator 0. The square root or any even root of a negative number is not a real number. Okay, so for now we're going to exclude those as well. So let's see if we can determine the domain. What type of function is this in general? We call it a polynomial, right? And so what kinds of things can we plug into polynomials? What kind of things can we not? Anything works for a polynomial. Okay? So we'll say that the domain is all real numbers, which we can write as that, or I don't know, in your textbook they may have done something like this. Okay, minus infinity to infinity. Okay, b is also a polynomial. In particular, it's a linear function, so we know its domain is what? All real numbers. We can put anything in for any polynomial. Okay, but c is a rational function because it has a numerator and denominator, and so we're concerned about anything that would cause our denominator to be what? 0. Okay, so we're going to exclude 2. Very good. 2 minus x equals 0, or 2 equals x. Okay, we're going to exclude that, but also this isn't just 2 minus x in the denominator, it's the square root of that. And so with square roots or radicals, even radicals anyway, we don't want what kinds of numbers? Negative numbers. So I also need to have it such that 2 minus x is greater than 0. Okay, a couple of things that you really need to pay close attention to here. If we were just looking at the radical, 0 would be okay. All right? But because it's in the denominator, that's why we're excluding whatever causes it to be 0. Okay, so 2 minus x greater than 0 gives us 2 greater than x. Those things work. Or x is less than 2. All right, so that's it. Our domain is x less than 2. The 2 is excluded. Okay, so if we write this in our interval notation, it's what? To 2, parenthesis. Okay, questions about that one?
On this one, you want to do infinity?
No, because we just said that it had to be less than 2. Okay, anything larger than 2 is going to cause the denominator to be, or what's beneath the radical to be negative, and that would be a problem. Let me open this door. Okay, what about in D? Okay, we still don't want our denominator to be 0. So x squared plus 5x plus 6 equals 0. We're excluding anything that would cause that to be true. To solve this, we need to do what? Factor. And this factors as, okay, x plus 3 times x plus 2 equals 0. X plus 3 equals 0, or x equals negative 3. X plus 2 equals 0. X equals negative 2. We're excluding these things. So I'm going to write this as minus infinity to negative 3 union negative 3 to negative 2 union negative 2 to infinity. Okay, because we're using parentheses on those ends, that means the negative 3 and the negative 2 are excluded. They're not included there. Okay. Can it be 1? Oh, up top, there's nothing wrong with the numerator being 0. Just the denominator. Okay, other questions? Okay, very good. Okay, we can determine if a graph is the graph of a function by using what's called the vertical line test. Okay, vertical line test. Oh, we're on the last page. Okay. The vertical line test is if no vertical line intersects the graph of a curve at more than one point, then the curve is the graph of a function. Why would a vertical line crossing our graph at more than one point violate the definition of function? Exactly. One x value would have two y's, just like you see here in the picture, right? Here we have a vertical line that comes through the value x equals a. So that means a maps to c, and it also maps to b. Okay, so that's why the vertical line test works if we have a graph.
So is that a function?
This one is not a function. That's right. Okay, not a function. So when we look at these examples, okay, determine which of the graphs below is the graph of a function. What about B? Okay, no, it's not. Okay, not a function. And C? Yes, C is a function. Okay, what about this circle? No, not a function. Okay, and D. Okay, yes, very good. All right, so don't forget about the vertical line test. If we have a graph, it's a very quick way for us to determine whether or not that graph represents a function. Look at graphs and what else they can tell us about our function. In particular, what we want to be able to do is figure out what the domain and range of a function are from its graph. Does everyone have this handout or the notes? No? Who needs it? All right, the rest of the notes are in the bookstore, so you can go on and pick those up for about $6. Okay, so when we look at this, it says to determine the domain of the graph, find the x values that the graph spans along the x-axis. Okay, so when I look at this first graph, and I want to figure out what its domain is, I see that the graph spans from here, this x value, to this x value. Okay, so we're talking about this range. So our domain would be what? No, not negative infinity to infinity. This graph actually stops here and here. That's what the solid points indicate for us. If it had a line, we might say minus infinity, or an arrow, minus infinity to infinity. But these points say this is it. So what is the x value right here? -1. We're going to use a square brace because it's included. And then we're going to go all the way over to what? 3. And that's also included. Okay? To get the range, we're looking at the coverage of the y values. Okay? So where does it go as far as y values? Okay, that's the minimum y value. And this is our maximum y value. Okay, so the minimum y value is what? -2. And again, it's included. Maximum y value is 4. Okay, so we were able to determine the domain and range from the graph. Okay, questions about that? All right, what about in this next one? What would we say the domain is? This time, on the left, we've got what? Negative infinity. We've got the arrow is going on, so we'll say negative infinity to 4. Very good. Okay, it stops, and that should be a square brace. It stops right here. Okay, that's the end of it. Okay, then as far as the range, what's the minimum value? -1, and that is included. And then it goes up to what? 3. Is that included? Yes, it is. Okay. Looks like once it gets to -1, the value stays at 3. Okay. Questions about that? Okay. Very good. Okay. We've got C and D. Take a look at those. Well, let's do C together, and then we'll do D. I'll let you do D. Okay. What about the domain for C? Very good. Not included. Excellent. The open circle says it's not included. 1, 2, 4. Very good. And the 4, again, is not included. Okay. Questions about that? All right. And then for the range, what would that be? Okay, -2 is the minimum value, and it goes up to 4. Okay, 4 is included, but the -2 is not. All right, questions about this? Okay, very good. Try D on your own. Okay, so our domain in this case is what? Okay. Very good. All right. And what about our range? Very good. Okay, questions about that? Okay, great. All right, let's talk a little bit about some functions in economics. All right, in economics, some definitions that we should be aware of. We're going to use X to represent the number of items manufactured or sold at a price of P dollars. Okay, the cost, C of X, represents the costs of the function and includes fixed costs and variable costs. Fixed costs are those things that we incur before we even manufacture or purchase the first item. And then variable costs are those costs which depend on the number of items sold. Okay? So in short, our cost function is equal to variable costs plus fixed costs, or mx plus b. Okay? Mx plus b is our slope-intercept form of the equation of the line, where the slope is applied to each individual item. So that's going to be our variable cost. And b is the cost that we incur, or the setup cost that we have before we even make the first item. Okay? Let's see, the other function we want to know about is revenue. Revenue represents, or R of X represents, the money brought in from the sale of X items. Okay, what we collect at the register. It's the price per item times the number of items sold. And then finally, profit. P of X represents the profit or gain from the sale of X items, and is simply revenue minus cost. Okay? All right, sometimes we're interested in the break-even point, which is the point or the number of items sold such that the company neither makes a profit or a loss. Okay? We break even. And so we need to be familiar with all of these terms. Okay, a company will have a profit if P of X is greater than 0. Okay, they'll break even if P of X is what? Equal to 0. They suffer a loss if P of X is less than 0. Okay, so that's how we interpret those things. All right, so here we have an application. Capitol Records Company plans to produce a CD by the popular rapper Rap-It. The fixed cost is $500,000, and the variable cost is 50 cents per CD. The company sells each CD to record stores for $5. Let X represent the number of CDs produced and sold. They want us to find the cost, revenue, and profit function. Okay, so we just said that cost equals variable cost plus fixed cost. Okay, so what kinds of costs? Well, they tell us exactly. What's the fixed cost in this case? Okay, the $500,000. Okay. Okay, the variable cost is 50 cents per CD. So if X represents the number of CDs, then it's very good, 0.5X plus 500,000. So C of X equals 0.5X plus 500,000. Okay, that's how much it costs them to produce these X or create these X CDs. Okay, then they're going to sell it to the store for $5. So we can come up with what from that information? Which function? Which one? Not P of X, not quite. First we have to come up with R of X, the revenue. And so they're selling it for $5 per CD. Okay? And now we can come up with the profit. P of X equals R of X minus C of X, or 5X minus 0.5X plus 500,000, or 4.5X minus 500,000. Questions about that? Okay, good. All right, part B says find the cost and revenue if 100,000 CDs are made and sold. How much profit will be made? Okay, so if we want to find the cost, we're going to look at C of 100,000. Okay, so if we plug in 100,000 into 0.5 times 100,000 plus 500,000, and it sounds like 450,000 or 550,000 to me. Is that right? Okay, that's the cost. The revenue is going to be what? Okay, the revenue at that point is 500,000. Okay, and the profit at that point is what? I'll just say revenue minus cost. And so if we do revenue minus cost, we get what? Y'all stop talking to me. I got negative 50,000. Okay, negative 50,000. Okay, so if they only get to sell to the stores 100,000 of these CDs, then they're going to have a loss. Okay, how many CDs must be sold for the company to break even? Okay, well, we said in order for that to happen, we need what? P of X to equal 0. Okay, and so P of X we saw was 4.5X minus 500,000. Okay, we want that to equal 0. 4.5X equals 500,000. And if we divide both sides by 4.5, we get what? Anybody? I got 111,000.111. It says round to what? To the ones place? Okay, so we'll say 111,111 CDs. Okay? Questions about this? Okay. Where to get? Okay, well, we were looking for the profit function, and in our profit function, when we simplified it, we got 4.5x minus 5,000. Okay. To get the profit function, we did revenue minus cost. And so when we subtracted 5x minus 0.5x, gave me 4.5x. All right, other questions? Okay, good. Oh, there's a part D. How many CDs must be sold for the company to make a profit of 750,000? So again, our profit function is what? Was it 4.5? Okay. Okay, minus 500,000, and we want a profit of 750,000. Okay, so I set my profit equal to 750,000. Going to add 500,000 to both sides. Is that right? And what do we get? Okay, very good. That's a lot of CDs. Okay, questions about this? All right, very good. All right, here we have another application. It says a stone thrown upward with an initial velocity of 240 feet per second will attain a height of h feet in t seconds, where h of t equals 240t minus 16t squared. Okay, for 0 less than or equal to t less than or equal to 15. Okay, so we've seen problems like this before, hopefully in your intermediate algebra class. But here it says, what is the domain of h? What is our domain? Okay, 0 to 15. Very good. Okay, these are the values that our variable t can take on. They tell us that. Okay, they want us to find h of 3 and h of 10. So if we look at h of 3, okay, what do we get? Come on, somebody help me. Okay, 576. Okay, and h gives us the what? $576 what? Feet. Okay, very good. Okay. All right, so after 3 seconds, this object will have reached a height of 576 feet. Okay, if we look at h of 10, we get what? Was it 800? Okay. So after 10 seconds, it will have reached a height of 800 feet. Okay, questions about this? All right, very good. How long will it take for the stone to hit the ground? How do we figure that out? Set it equal to 0. Okay, we want to know when is h of t equal to 0. And h of t is represented by 240t minus 16t squared. Okay, if we want to know when it's going to hit the ground, we set the height function equal to 0 and solve. How are we going to be able to solve this? First, we have to factor, right? We can factor out at least 8t. I don't know if 16 goes into 240. So let's just start there. No? It does? Okay. All right, so let's factor out 16t. And we're left with what? Okay, 15 minus t equals 0. Okay, so we get 16t equals 0, or 15 minus t equals 0. Okay, when we solve over here, we get t equals 0. And then when we solve here, we get 15 equals t. The question, though, is when does it hit the ground? What would we say? At 15 seconds, okay? Hits the ground at 15 seconds. What's happening at 0? Okay, the process is starting, and it starts from the ground. So that's why we got that solution. But in order for it to hit the ground, it first has to leave and then come back down. Okay, we factored it out, right? And this is what we call the zero factor property. We've got a product here. 16t is one factor, and then 15 minus t is the other. If we have some factors and their product is 0, we know that at least one of them has to be 0. So we take each... Well, no, we try to avoid dividing by a variable if we can. Okay? So, yeah, we factor and set it equal to 0. Okay? Very good.